We are continuing the previous lecture. So we have seen fluid properties in the previous lecture. Now we will see some kind of problems related to fluid properties. So basic things. The first one, fluid properties problem. Calculate the specific weight, density and specific gravity of 1 liter of a liquid which weighs 7 newtons. So now they have asked three questions. One is specific weight, density and gravity. So with respect to 1 liter of a liquid which weighs are 7 newtons. So now first we have to write the given data to make it easy. So now we can see how much water they have given. 1 liter of water. So 1 liter is also equal to 1 by 1000 meter cube. In a simple sense, 1000 liters equal to 1 meter cube. Remember this thing, 1 meter cube equal to 1000 liters. From that, 1 liter equal to 1 by 1000 meter cube. And already weight they have given 7 newtons. So two inputs they have given. One is in terms of liters, that is 1 liter equal to 1 by 1000 meter cube. And another one is 1000 like 7 newtons. Now they have asked us to find three things: specific weight, density and specific gravity. Agree? Specific weight, density, specific gravity. Now let us try to find each and everything because we already remember the formulas. Now first one, specific weight. So specific weight definition is nothing but weight by volume, as we have discussed in the earlier lectures. So what is the weight? Already they have given weight is 7 newtons. See here they have given. And okay, what is the volume? Volume equal to 1 by 1000. Agree? Then 7 by 1 by 1000, that is nothing but, if you are making 7000 Newton, already weight they have given in terms of Newton, and 1 by 1000 already we know that it is in meter cube. So units is Newton per meter cube. So this is what required. So one stage we have completed, that is first one, specific weight. Now second one we'll go with density. So density means already we have known this formula, density equal to mass into gravity. Agree? Already I have taught you. So density is nothing but rho. So already we have gone through the relation of specific weight. Specific weight by G. So density equal to specific weight by G. And now specific weight is already we have calculated, that is 7000 and it is 9.81. So what is the density? 713.55 kg per meter cube. So density equal to specific weight by specific weight by gravity. Gravity is 9.81. Now third one, specific gravity equal to, so specific gravity always density to the reference density. What is the density? Density of liquid to the density of water. What is the reference they have given? Water. So that is equal to 713.55 divided by density of water. As I mentioned, it is 1000 the value. Now density of liquid by density of water. So both you can do. Specific gravity is denoted by S, 0.7135. Okay, 0.7135. So now we understood, if we know the basic fundamental formulas about the fluid properties and basic definitions, what is specific weight and what is specific density and specific gravity, then it is very easy to calculate. The question. So once we will see the answer, which I have written in a good format, like given data, volume equal to 1 liter equal to 1 by 1000 meter cube and weight is equal to 7 newtons, and specific weight, density and specific gravity we have to find. In that specific weight equal to weight by volume. Weight already they have given 7. So already they have given 7. So here we have considered 7, and from this 1 by 1000 already we have 1 by 1000. So directly we are getting 7000, and we know that weight density is equal to mass density into G. Rho is equal to specific weight by G. That is a specific weight already we have calculated 7000, and gravity is 9.81, that we know and we should know, and rho equal to 713.557 kg per meter cube, and specific gravity equal to density of a fluid by density of the water. So density of a liquid is nothing but 713.55 by standard density. Reference density of water is nothing but 1000. So specific gravity is 0.7135. One more problem we will see in a similar way. The first thing, when we are doing any kind of problem, we should understand the question first of all, and second thing, we should know what is the given data, then how we are going to solve that. So first we understand given data, then it is very easy to tackle the problem whatever they are mentioned. Now we will see the so the calculated density. So okay, density as like previously, specific weight and weight. Specific weight and weight, but previously they have mentioned specific gravity, right? Now previously they have given directly weight as 7 newtons. Agree? But now they have given directly with respect to the specific gravity. So something reverse. So something interconnection should be known before proceeding this problem. So similarly, volume equal to 1 liter equal to 1 by 1000 meter cube, because as they mentioned here clearly it is 1 liter of water. Okay. Uh, Next it can be another one, that is equal to specific gravity is denoted by S, that is 0.7. Now coming to the picture, first one is density. Now density, specific weight and weight. Now as we know that specific gravity equal to density of liquid by density of water. Okay, agree? This is a standard one. So already we know the specific gravity, already we know this is 1000. So density of liquid, we can find density of the density of liquid equal to 0.7 into 1000. So that is equal to 700 kg per meter cube. So that's the thing. Now second one is specific weight. So first one density we got, second one is specific weight. Specific weight is equal to, as we know, W is equal to rho into G. Now specific weight is equal to 700 into 9.81. So W is equal to 6867 Newton per meter cube. So next third one. So next one, weight. Just they are asking weight. So for that, specific weight equal to weight by volume. Now weight is equal to specific weight into volume. Now weight is equal to, what is the specific weight? Specific weight already we have calculated 6867 into volume, we know 1 by 1000. So W is equal to 6.867, 6.8 newtons. So that way we have to calculate each and everything. So we should know the interconnectivity between the fluid properties standard formulas. Then it is very easy to calculate the problems. So once we will see how I calculated. So first given liter, volume equal to 1 liter equal to 1 by 1000 meter cube and specific gravity is 0.7. Next, specific gravity equal to density of liquid by density of water. Then density equal to specific gravity into density of water, that is 0.7 into 1000, that is equal to 700. So W equal to rho into G, that is equal to 700 into 9.81, that is 6867 Newton per meter cube. Next, specific weight is equal to weight by volume. So weight is equal to W into V. Already we have calculated specific weight and volume is 1 by 1000, that is equal to 6.867 newtons. So next problem we will see, the question is calculate the specific weight and specific mass and specific volume. So here three different things are there, and fourth one also there. It was specific gravity of a liquid having a volume of 6 meter cube and weight of 44 kilonewtons. So now every time we should write the given data. So volume equal to 6 meter cube, done, and weight equal to 44 kilonewtons. Now we will try to find one by one. First is specific weight. So as we know, until we know the standard formula definitions, it is very easy to find. Specific weight is equal to simple weight by volume. Got it? So that is equal to specific weight is equal to weight is 44 by 6, that is equal to 7.33 kilonewton. Already they have mentioned by meter cube. Done. First one is completed. So specific weight equal to volume, the weight by volume, and weight is 44 and volume is 6. So 7.33. And second one, specific mass. So specific mass equal to, as we know, W, that is specific, W equal to rho into G. Agree? Now rho is equal to W by G. Agree? So rho is equal to W means 7.33 into, that is kilonewtons per meter cube, convert into newtons per meter cube, that is equal to just addition of kilo, you write into 1000 by 9.81. So that is equal to 747.5 kg per meter cube. Now we got rho, but they have asked another one, that is third one, specific volume, that is equal to 1 by rho. 1 by rho means, already we have found rho, that is equal to 1 by 747.5, 0.00134 meter cube. Fourth one, gravity. Gravity is equal to, as I told, like a specific, like a density of a liquid by density of water. So S is equal to 747.5 by 1000, that is equal to 0.747. Now this is the final one. We will see volume equal to 6 meter cube per second and weight is equal to 44, and we have to find specific weight, specific mass, specific volume, specific gravity. And specific weight equal to weight by volume, that is equal to weight by volume is 44 by 6, that is 7.33 kilonewtons per meter cube. And specific mass or mass density is equal to W by G, that is equal to 7.33 into 1000 by 9.81. So 7.33 into 1000 by 9.81, that is 747.5 kg per meter cube. So specific volume equal to 1 by rho, that is equal to 1 by 747.5, 0.00134 meter cube per kg. Specific gravity equal to mass density of liquid by mass density of water. Yes, specific gravity equal to 747.5 by, that is 747 is liquid, that is density, already we have gone, we know this here, and by 1000, that is equal to S is equal to 0.7475. Similarly, we will solve another problem. So now the slowly, the step by step is increasing the level. Now if 5 meter cube of a certain oil weighs 400 kgf, calculate the specific weight, mass density and specific gravity. Here they are telling specific weight, mass density and specific gravity. Now they are telling 5 meter cube of a certain oil weighs 4000 kgf. So now the first one we will go specific weight. The formula is weight by volume. So what is the weight? Obviously they given 4000. What is the volume? 5. Just keep the thing 800 kgf by meter cube. That's it. So if you know the formula, you will get within seconds. Specific weight is equal to weight by volume, that is equal to 4000 by 5 into 800 equal to kgf by meter cube. If you want to convert it into like kgf per meter cube, need to be converted into Newton per meter cube. For example, just multiply with 9.81, that is equal to 800 into 9.81, that is equal to 7848 Newton per meter cube. That's it. The second one, mass density. So mass density equal to specific weight by G. What is the specific weight? 7848 by 9.81. So that is equal to specific weight already we know, gravity we know. So 800 kg by meter cube. Now third one, specific gravity of oil, that is equal to final one, specific gravity of oil equal to specific weight by of oil, always with reference to water. So specific weight of 800 by 1000 equal to 0.8. Understood? So if you are able to understand the relation between the fluid properties, then it will be very simple problems. Specific weight equal to weight by volume, that is equal to 4000 by 5 equal to 800, and specific mass density is equal to specific weight by gravity, that is 7848 by 9.81, that is equal to 800 kg per meter cube, and specific gravity of oil equal to specific weight of oil by specific weight of water, that is 800 by 1000, that is equal to 0.8. So here I have mentioned clearly. If you people are not able to understand the writing, you can see here specific weight equal to weight by volume, that is equal to 4000 by 5 is equal to 800, and that is converted to Newton per meter cube, that is equal to 800 kgf by meter cubic into meter cube into 9.81, that is a 7848 Newton per meter cube, and mass density equal to specific weight by gravity, 7848 by 9.81, that is equal to 800, and specific gravity of oil, that is equal to specific weight of oil by specific weight of water, that is equal to 800 by 1000, that is equal to 0.8. So this way it need to be solved. So next, one more problem which is similar kind of problem, we will try to solve it. A 5 meter cube of a certain oil weighs 40 kilonewtons. Okay, and calculate the specific weight, mass density, and specific gravity of this oil. So specific weight equal to weight by volume, that is equal to 40 into 1000 by 5, because kilonewton, so we are converting it to Newton, that is equal to 8000 Newton by meter cube. So second one is mass density. Mass density equal to specific weight by gravity. So 8000 by 9.81, that is equal to 815.5 kg per meter cube. And third one, specific gravity equal to reference with respect to the reference. Now we can see specific weight of a liquid of an oil, specific weight of an oil is equal to 8,000 with respect to reference is nothing but it was 10,000, that is equal to 0.8. So here we can see specific weight equal to weight by volume 40 into 1000 by 5 meter cube equal to 8,000 Newton per meter cube. Mass density of oil equal to mass density equal to specific weight by G, that is equal to 8,000 by 9.81, that is equal to 815.5. And specific gravity equal to 8,000 by 10,000 equal to 0.8. So one more problem we will see. So this is completely related to capillary rise. Determine the maximum size of the glass tube that can be used to measure water level. If the capillary rise in the tube is not to be exceeded 0.33 mm, that is equal to H is equal to 0.3 mm. That is the one concern they are giving. And second one is take surface tension of the water in contact with air as that is equal to gamma W equal to 0.0735 Newton per meter. This is what they have given. Capillary effect, as we know, the standard formula H is equal to 4 sigma cos theta by rho GD. Got it? So already we know H is equal to 0.33, 0.33 into 10 power minus 3, that is equal to, we are converting mm to meter, and 4 into sigma is 0.0735 into cos 0 degrees and by rho is equal to 1000, G is equal to 9.81 and D. So assume that theta is 0 degrees if anything is not given, such that D is equal to 0.1 meters, that is equal to D is equal to 100 mm. D is equal to 100 mm. Now we will see clearly in a written format. So they have given capillary as H is equal to 0.3 and sigma is equal to 0.075 Newton per mm, Newton per meter. Next, to find diameter of the glass tube, we have to find. So capillary effect is H is equal to 4 sigma cos theta by rho GD. So here 0.33 into 10 power minus 3, that is capillary effect. 4 into sigma, that is 0.0735 into cos theta, that is equal to 0 by 1000 into 9.81 into D. Assuming theta is equal to 0 degrees for water, then d is equal to, we can find from this thing, d is equal to 0.1 meters, that is equal to d is equal to 100 mm. So this way, so now you can revise it. So initially the first problem, specific weight, density and specific gravity. So with respect to given data, volume and weight, we have calculated it. And second one, with respect to volume and specific gravity, instead of weight, they went with specific gravity, we have calculated density, specific weight and weights. And volume and weights, again, they once what they have given specific weight, specific mass and specific volume and specific gravity we have calculated. And coming to the thing, specific weight of volume and mass density of oil and specific gravity of oil we have calculated. And another one, specific weight of oil, mass density of oil and specific gravity of oil for the other things with respect to the different things we have calculated. So determining another one, capillary one. So here capillary effect, we should know H is equal to 4 sigma cos theta by rho GD. That is very important one. Also rho GD. So we will see in the next class and two more problems. Okay, we will see in this class itself. So calculate the capillary effect in a glass tube of 2.5 mm diameter when immersed vertically in a water and mercury. So previously we have done directly with one thing, but here we are doing with water and mercury. So now they have given sigma for both water and mercury, and angles also they have given 13.6. Specific gravity they have given for mercury is 13.6, and angle they have given 130 degrees. This is in degrees. This is degrees actually. So now we know H is equal to 4 sigma cos theta by rho GD. Now I am going with respect to water. H is equal to 4 into, what is the sigma for water? 0.0725 into cos 0 degrees. That is the thing, and 1000 into 9.81 into D, already they have given 2.5 into 10 power minus 3. So H is equal to 0.0118 meter. Now we are going another H, that is mercury. H mercury is equal to, this is, you can treat it as water. So same formula we can go, that is equal to 4 into 0.52 into cos 130 degrees. So here rho is not 1000, that is what, 13.6 into 1000 because of mercury, and 9.81 into 2.5 into 10 power minus 3. So H mercury equal to minus 0.004 meters. So this minus value indicates depression. So here I have clearly mentioned, this is for with respect to water, you can see, and this is for with respect to mercury, and H is equal to 4 sigma cos theta by the rho GD, and I have substituted everything. I got 1.18 centimeters, and here everything I have substituted, and I got minus 0.04 centimeter. That is minus means depression. So this way we are calculating, and in the next session we will see some more problems and the content related to this.